Next up, we want to talk about half angle identities. These are going to be just like our double angle identities, but we're going to turn them around. Notice that 2A is twice as much as A, but A is also half as much as 2A. So contained in our double angle identities, I'm just going to reframe the double angle part of the identity to be the half angle part of the identity. So what we're going to do is we're going to solve for cosine of A and then solve for sine of A in our double angle identity for cosine. So we're just going to take our double angle identity and turn it around. So 2A is double A. So that means A is half of 2A. Two A is double A. That's where the double angle identity comes from. A is half of 2A. So this is where we're going to get our half angle identity. I'm going to solve the double angle identity for cosine for the cosine of A. Just going to reframe things. So here's how we can reframe things. I can say that 2A is equal to, let's say, K. That means that A is K over 2. That's how things are going to be reframed. So I can write this, instead of saying cosine of 2A, is equal to some K. And so that means A would just be K over 2. And there is the half in our half angle identity. Now we're just going to solve for the cosine of K over 2. So there's our half angle. So notice that what we're solving for, cosine of K over 2, that's being squared. So there is going to be some plus minus shenanigans running around. So we're going to have to think about how to deal with this plus minus shenanigans stuff. But let's solve for cosine of K over 2. What's happening is we have cosine of K over 2 is being squared. It's being multiplied by 2, and we're subtracting 1. The first thing that happens to cosine of K over 2 is it gets squared. Then it gets multiplied by 2. Then we subtract 1, so we'll solve by doing inverse operations in reverse order. So the cosine of K plus 1 is 2 times the cosine squared of K over 2. Next, we can undo the multiplying by 2 with some dividing by 2. So a half of a cosine of K plus 1/2 is cosine squared of K over 2. We may not like thinking about it this way. I just divided everything by 2. So from an alternate reality standpoint, you might like, oh, I don't like this. I'm just going to write it over here. Sometimes we see this as cosine of K plus 1 all over 2. All I want to find out, I don't want to get all the way down to K. I just want the cosine of K over 2. So now we have to do the square root parts. When we're undoing an even exponent, that's where the plus and minus shows up. So cosine of K over 2 is plus or minus the square roots of cosine K plus 1 over 2. So this is a half angle identity. It's got a plus or minus in it because we solved in an equation that involved an even exponent. That led us to 2 solutions. Now the cosine of some angle can't be both values. So it's plus or minus depending on the quadrant that k over 2 is in. So the plus or minus that you use depends on which quadrant. Use plus if the angle k over 2 is in quadrant 1 or quadrant 4, where cosine is positive. Use minus if the angle k over 2 is in the other two quadrants, quadrant 2 or quadrant 3, where cosine is negative. So you use plus or minus depending on whatever quadrant k over 2 is sitting in. So the half angle identity just come from our double angle identity. Taking our double angle identity and kind of reusing it for some other purpose. We could do the same thing in the other column for sine of A. I can do the same kind of thinking. 2A is double A, but A is half of 2A. So I can write cosine of K is 1 minus 2 times the sine squared of K over 2. And then I can do the same thing. I could solve this for sine of K over 2 to get my half angle identity for sine. Yes. Yeah. No, this is a different, this is just a K from here. 2A, I'm just renaming 2A as K, so I could call A K over 2. I've used it for it. K shows up a lot in as the vertex, the y coordinate of the vertex. So HK is the vertex. So now I can do the same thing here. I want to solve for sine of K over 2. We've squared it. We've multiplied by -2, and we've added 1. So let's just do inverse operations in reverse order. Subtract 1. Now we'll divide by a -2. So we have a cosine of K minus 1, but it's divided by a -2. We do not like this, dividing by -2, when there's subtraction sitting right in the numerator. So here's what we do. I'm going to change all the signs. Just change all the signs. And that changes the order. So instead of writing cosine K minus 1 over -2, that looks terrible. I don't know if you look at that and see that it looks terrible. But by the time you get through calculus, you look at that and it'll be like, ugh, that looks awful. And everybody else will be like, oh, I know, right? But here in trig, it's like, well, who cares? Dividing by -2. It's like, oh, no. I have to program you through prejudice right now. It's like, oh, that looks bad. That's bad. So we're going to change the order. Change all the signs. If I change the -2, I got to change this minus to a plus, but I also got to change this plus to a minus. And since instead of writing minus cosine of K plus 1, I'll just change the order and write 1 minus cosine of K. And we'll do it like the cool kids do it. Once again, we got to undo an even exponent. This is going to do a plus and minus square root so that we get to the sine of 2K, or sorry, sine of K over 2 is plus or minus the square root of 1 minus cosine K over 2. And on this one, the plus and minus decision is the same plus and minus decision that we had for cosine. It's plus if K over 2 is in quadrant 1 or quadrant 2. And use minus if K over 2 is in quadrant 3 or quadrant 4. It's plus if in the quadrants where sine is plus, it's minus in the quadrants where sine is minus. And just by looking at K over 2, we'll be able to determine what quadrant that's in. The half angle identities are the least remembered ones. Not sure why that is, but these are the least remembered ones. Probably because it's a plus or minus big giant square root. People just like naturally don't like it. Also, they aren't as self-reinforcing as the other one. With the cosine and the double angle identity, with the cosine squared minus sine squared, that helps you remember your sum and difference, cosine, cosine, sine, sine. But both of the half angle identities are based on that double angle identity for cosine. The two alternate forms, 2 cosine squared minus 1 and 1 minus 2 sine squared. Any questions? Comments? Snide remarks? Deep thoughts? Yep. All we're doing all day. We just wrote down those sum and difference identities, moving that stuff around. Mm-hmm. Yes. And when we undo an even exponent, the inverse of a exponent of 2 is an exponent of 1/2, which we usually write as a square root. And when we undo an even exponent and we're solving, that always produces a plus and minus. Even exponents can produce that plus or minus. We want to learn our sum and difference identity. We want to use our sum and difference identities to figure out our double angle identities. Then we can use our double angle identities to get us our half angle identities. You don't want to try to learn these in pieces. If your plan is to memorize them, first of all, find a better plan. You don't have to memorize them. You have to remember them. But you don't want to do it in pieces. You want to do look at all of the parts and know how they're related. That will help you remember. It's like when you're trying to learn a song. You can't just learn each verse separately. You have to learn how the verse goes into the chorus. Otherwise, you'll have this awkward pause. You can't just learn the individual lines of the verse. You have to learn how the first set of lines from the verse go into the second set. Otherwise, you'll have a pause in that kind of transition when you go from the first half to the second half. That make sense? I don't know how you would remember lyrics, but you got to know your transitions as well. So look at the whole thing rather than just the pieces. Hello, Robert. Any questions? Comments? Deep thoughts? Never any questions. You're just like, oh, no, this is cool. Everything's fine. We're all fine here. If y'all don't come up with something for me to talk about, I wouldn't keep talking about this. I don't know if you know this, but this is fun for me. Everybody looks very pained right now, but I think it's cool the way this is all connected. All right, that's gonna do it for today. It was just, let's see, oh, it's kind of like 4, 5, 6, 7, 8 new identities. You need to remember. Because the sum and difference is like 2. That's like 4. All right. Start looking at these identities by writing them down and remembering how to transition from one to the other. Double angle identity, just make A equal to B. Half angle identities, just turn your A into a K over 2 and solve for the cosine of K over 2 and sine of K over 2. That's going to do it for today. I will see you all on Thursday. Welcome back from spring break. Everybody have a good couple of days, and thanks for playing.